Hello, I'm Mr. Muskeluk, your AP Chemistry
Let's do
teacher
a
at
quick loose
ChemAdvantage.
electron dot diagram to approximate the shape and properties of chlorine trifluoride. Nice logical name. Well, we've got one chlorine and four fluorines, and if you're doing Lewis dots, you should remember that chlorine, with all the halogens, has 7 valence electrons. So we have one of them. So 7 valence electrons for chlorine. And then we've got 3 fluorines, which is a halogen also. So 3 of them, 3 times 7 would produce 21 valence electrons. And our total number of electrons to play with in this Lewis electron dot diagram would be 28 valence electrons. Quite a few valence electrons for 4 atoms. So we've got them arranged here. Chlorine's got a little bit less electronegativity than fluorine. We'll put that in the center. And it's sort of logical to figure out that these 3 fluorines would be around it. So the next thing we've got to do is bond these. Put a pair of electrons between each of these that they'd be sharing, a fluorine sharing this pair, chlorine sharing this pair, making a covalent bond, a lower energy structure. So we're going to have to do that for 3 of these fluorines. So let's see what that looks like here. 2 electrons, 2 electrons, 2 electrons. That's what those lines stand for. It's nice showing them as a line indicating that there's a bond, but we know those are a pair, 2 electrons, and 1 orbital being shared by 2 atoms. So that removes 6 of these 28. That leaves 22 electrons to be somehow distributed around here. And our rule is that we give these electrons first to the surrounding atoms to complete their octets. So if we do that, we're going to put electrons around one of the fluorines right here. 2, 4, 6, another 2, 4, 6. Now let's not forget this third fluorine, 2, 4, 6. Of course, if you've been keeping a tally, 3 times 6 is 18. That removes 18 electrons for the surrounding atoms. That's our procedure, quick procedure to figure the loose electron dot diagram for chlorine. Well, if we used up 18 of these 22, we've got an extra 4 electrons that are remaining. Those remaining electrons go on the central atom. Chlorine is a 3rd energy level, so it's got room for more than 8 electrons. It's got a D subshell where those electrons can be used as locations for them. So we put them in pairs in the central atom, and let's see what that looks like. There they are, 2, 4, each of these in an orbital. So that takes care of all of our electrons. We've used up the 4 remaining. They're in the center. If you count these lines as 2 electrons each, and our other electrons, you've come up with, like I said, a lot of electrons, 28. So this is an electron-rich molecule. We've got a lot of them. If you wanted to find the shape of this, if you determine that this is the Lewis electron dot diagram, you'd go to a shape table, and we've got one here for our class that we've used where we have to deal with, let's go back to that diagram, a total of a central atom. That's going to determine our shape, where we have 1, 2, 3, 4, 5 pairs of electrons to deal with in terms of geometry. And that shape with 5, a steric number of 5 pairs of electrons in space is right here. If you've got attachments for all of these, you've got a trigonal bipyramidal, but we've got 2 free electrons, and that'll help you determine, let me scroll up there, what the actual shape of this would be. These electrons take up a little bit of extra space, so they'd pinch these 3 atoms a little bit closer together. In terms of formal charges, well, let's see what we can produce with that. We'd have to circle each one of these atoms, and That's what I've done here. We've put a circle around each one of these atoms to see the electrons that they control. A fluorine has 1, 2, 3, 4, 5, 6, and it has one of the electrons in this bond, 7. Well, fluorine normally has 7, so we're good with that. That's a formal charge of 0. The same will happen with this fluorine. The same will happen with this fluorine. Our chlorine is a little bit different. We've got 1 electron in this bond, second one, third one, 4, 5, 6, 7. A total of 7 electrons is what you'd expect for chlorine, and we've got formal charges of 0 all around here. So this looks like a very logical diagram, and we could determine, as I said, its shape using a shape table right here. So we've done the Lewis electron dot diagram for chlorine trifluoride right here.